Hey everyone, welcome to your lesson summary video on applying the quadratic formula, part 1. Quadratic equations that represent situations cannot always be neatly put into factored form or easily solved using square roots. Completing the square is a workable strategy, but for some equations, it may involve many cumbersome steps. Graphing is also a handy way to solve the equations, but it doesn't always give us precise solutions. Well, thank goodness we learned about this with the quadratic formula. We can solve these equations more readily and precisely. For example, function h models the height of an object in meters t seconds after it is launched into the air. It is defined by h of t equals negative 5t squared plus 25t. So this h of t right here, that is representing the height of the object. And then this is representing where the object is after however many seconds. T is representing your seconds. So you can kind of picture, something is going to the air and coming back down as time goes on. So how high is that at any point? And that's what our function would give us. So to know how much time it would take the object to reach 15 meters, so that is a height measurement they're giving us, we can solve the equation. So instead of h of t, we're going to replace that with 15. We want to know, when is the object 15 meters high? And so negative 5t squared plus 25t. So we can solve that equation, but how should we solve it? Rewriting it in standard form would give us, if we just subtract 15 from both sides, we would have that negative 5t squared plus 25t plus or minus 15 equals 0. So there's standard form. There's your ax squared plus bx plus c equals 0. The expression on the left side cannot be written in factored form, however. So this is not something that we could factor, so we wouldn't use factoring as a method of solving. Completing the square is not convenient because the coefficient of the squared term is not a perfect square. So this negative 5t squared, that's not a perfect square term, so we wouldn't want to use completing the square. Let's fill in perfect square. And also the linear term with the t to the first power, that's an odd number. So that's just going to make completing the square a little bit trickier. You would end up with fractions anytime that's odd. So let's use the quadratic formula, where we know a is negative 5. There's a negative 5 with your t squared. B is 25. There's a 25 with a t, and your c is a negative 15. So quadratic formula, let's write it off to the side. As a reminder, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So all we have to do is fill in our a, b, and c values and simplify. So negative b, so our b value is a negative 25. If your b value was negative and you had that negative negative, that would turn positive. Plus or minus the square root of b squared, so 25 squared, minus 4 times our a, which is negative 5, times our c, which is negative 15, all over 2 times a, which is negative 5. So when you guys do the quadratic formula, the first thing we should simplify is whatever this number underneath the square root would give us. What's that b squared minus 4ac? So first we have that 25 squared. 25 times 25 is 625. Just remember, whatever number you're squaring here, whether it's positive or not or negative, will always be positive, okay? So we have 625, and then what I like to do is I don't even write a plus or minus next. I look at the next three numbers to multiply. So what I mean by that is if I were to kind of cover up, I already did the 25 squared. This is just three numbers multiplied together. It's a negative 4 times a negative 5 times a negative 15. So negative 4 times negative 5 times negative 15 is a negative 300. Because that's a negative 300, I'm going to put minus 300 right there. If that was a positive 300, I would have put plus. And then what is 625 minus 300? We get 325. That's a 5, it's hard to tell. All right, here's what we just figured out. If we go back to our quadratic formula, we have a negative 25 plus or minus the square root of, and we did all that math, and we got a 325 all over 2 times negative 5, which is negative 10. Our next step is let's actually take that square root of 325. So we have negative 25 plus or minus, and when we square root a 325, you get this decimal on your calculator. It's an 18.027. So I would say round to the nearest tenth, which in this case is just an 18.0. So I'm just going to leave it as an 18. Normally we would have like a point something here because 325 was not a perfect square, all over a negative 10. Now we break it apart. We're going to do the addition, so negative 25 plus 18 divided by negative 10. So negative 25 plus 18 is going to give us a negative 7. Well, that's a 7 divided by negative 10, which is a positive 0.7. Now let's do the subtraction. You have negative 25 minus 18 divided by negative 10. Negative 25 minus 18 is negative 43 divided by negative 10 is a positive 4.3. So we got these two solutions. They both are representing how many seconds it takes for this ball to reach, was it a ball? I don't remember. We're talking about an object is launched into the air. Okay. And the question was, how much time would it take to reach 15 meters? So just to show you quickly on a graph what we're talking about, like if this is our object that got into the air, and let's say this was 15 meters, that height, you can see, well, it's 15 meters here as it goes up, and it hits 15 meters here as it comes back down. So that's why we get these two positive answers, because in this case, after so many seconds, it hits the first 15 meters on the way up, and after so many seconds, it hits the 15 meters on the way down. So the solution tells us that there are 2 times after the launch when the object is at a height of 15 meters. Well, that's what we just said. So now we'll just fill it in. 0.7 seconds as the object is going up, and 4.3 seconds as it comes back down.